Welcome back, Science 9. Today we are going to start our lesson by going over these homework questions that I assigned in last class, which is Science in Action, textbook page 295, number 1, 5, 8, and 9. Let's start with our first one. The first question is asking, describe the charged particles in an atom. Well, theoretically, there are 3 subatomic particles, but because we are referring charged particle, I can think of 2. Number 1 is proton that has positive charge located at nucleus, which is a center of an atom. And proton, I like to say, cannot move freely. On the other hand, electron is another negative charge and is located at orbits actually. And this electron can move freely. Okay, the second question asks you guys to describe how a static charge might build up on you as you walk across a carpet. We did numerous times about this. I'm going to draw. Let's say this is Noah. And we have carpet. If he walked across the carpet, what happened is, inside of the carpet, we have equal amount of positive charge and equal amount of negative charge. Which I like to more randomly put these one. 1, 2, 3, 4, 5, 6. There you go. As Noah walked across though, there are 2 different type of situation can happen. Either electrons go toward him because we have friction occur, or rubbing if you will, between his shoes and the carpet. By having this friction, electrons can jump toward or away. In either case, it is okay. But let's say electrons are going toward him. Then he has more negative charge in him. So I like to say, by having this friction and rubbing between shoes and carpet, Noah now has excess electron. If you did other way, then please draw electrons away from him. If you did absence of electron, then you will naturally have a situation where Noah now has absence of electrons compared to the previous situation. Absent is actually a strong word because you cannot make it into 0. So maybe you can say Noah has less amount of electron in other situation. The third question is discussing about lightning and how its discharge can be dangerous, but it's more about building up. We're going to learn about lightning in detail. But fortunately, this stuff we can answer without knowing the knowledge that you will learn today. So I highlighted by friction between air and water molecule in cloud. And if there's a discharge, is it current electricity or static electricity? So 2 things that I need to discuss. I want you to think about very angry and dark cloud. Inside of the dark cloud has a lot of moisture in it. It's wet. That means we have a lot of water molecule inside. If we have a lot of water molecule, which I'm gonna draw it as a blue circle over here, then what happens is they will interact. Like pinball, if you will, or at one point, rubbing, if you will. This high interaction means high friction. That means it's gonna have a lot of electrons gathered at one area. Now, let's assume that a lot of electrons are located at the bottom. This phenomena itself, so what's going on in here, is static. But the question is asking about discharge. So, fancy way of saying, what happened? Imagine you have a ground over here, and hypothetically, let's say we have tall tree. Here's what happened. It is asking about the connection between cloud and the tree. In this case, I like to say circuit is built. Thus, I like to say this is current electricity. Now let's look at question number 9. According to the question, it says static discharge are classified as electricity but cannot provide the energy to a household device. Why is asking? Well, let's think about static discharge example. For example, static discharges sweater, friction, and zap that happening between people, you and whomever you touch, something like that. Yes, it is a jumping of electron, but I'm gonna say jumping of electron is not equal to flow, I like to say constant flow of electrons. It is just a single event, nothing more, nothing less. In order for us to have a energy to operate, we need two things. Number one, we need constant current, some kind of ampere as a unit that we can have it constantly. So current has to be constant. To do that, we need basically, I used this color before, you need wire and a completed circuit. You need that. Second, what do we need? We need voltage, which is, actually I'm going to say potential difference. Which is measured as a voltage as a unit because this provides potential energy. Like I said, potential energy is soon to be used as work or some kind of, like I said, work to operate something. We need these two. Thus, static discharge may exist as an electric zap or single event jump of electron, but it doesn't have a constant current, so we cannot operate it. So today we are going to conclude this chapter 1.3 electrical safety section. First of all, I wonder if you travel different places, globally, like not only Canada but also other places, because you will notice the plug shape is different. When it comes to Canada, we are using type A 110 volt, if you will, as a setting. But when it comes to South Korea, which is where I'm from, we use 220 voltage. So if you notice, every country uses slightly different amount of potential differences inside of their system. Sometime in Canada, you may see electronic device that has additional portion at the bottom. This is a safe grounding line, which we're going to learn in future. But in any case, every plug-in device sold in Canada must have a label listing what voltage is required and the maximum current it used. Like I said, for Science 9, we are using 110 volt in Canada and US, and that's good enough for you to understand. Technically 220 voltage, even though voltage is high, it's actually a little bit more safer. When it comes to electric shock, you need to understand a few things. If you look at the first picture, can you see that wire has a damage? Damaged wire basically mean exposed circuit. So if you touch those areas, what's going to happen is you're creating a short circuit. Sometimes rats and other rodents actually try to eat those cord and they zap and die because of that short circuiting. Even if the current rating is low, you need to get a shock if there's a short circuit or if the insulation is damaged. Last time, even though I mentioned about a little bit of electric shock and how it is important to avoid any type of electric cord damage that you see in the highway and so on, where the cord is droopy or when you're in the vehicle, you shouldn't come out, those kind of thing. But here's something that I want to point it out to you. It's quite common than you think. I want you to look at the plug over here. Can you see one of the end? I like to say terminal at the bottom. This was intended for grounding. But the thing is, that part is missing. Grounding means grounding in electric unit or any type of electrician work or something like that. It's a fancy way of saying let electrons go to Earth safely at one point. So it should theoretically, imagine this is electron, they should go through the device, let the device do the work, so potential energy do the work energy, and it should go back by the help of this terminal over here. But if that terminal is broken, then what's going to happen is instead of going through the plug-in, it actually can go through your body and then the grounding through your shoes, or if you're touching any other object, it may go there too. So your body is now a circuit. You're going to have an electric shock. Although there are multiple ways, if I list the safety guideline, I like to discuss 5 safety rules for electricity. Number 1, do not handle any electrical device when you are wet or near the water. This one is kind of obvious because water itself, H2O, is not a conductor. However, when it comes to tap water or your sweat, these guys have ions in it. Like your sweat is salty, so sodium ion and chloride ion, those kind of things. If you have ions, their ions solution, if you will, then it's a really good conductor. The second rule, a lot of households do this, which you shouldn't. Do not overload the circuit by plugging and operating too many devices. It's simple when it comes to this situation because what you guys see over here is basically overheat the circuit, wires if you will, inside of the circuit. Then, yes, you're gonna have a high heat energy, then you know the outcome, combustion, meltdown, whatever you name it. Third rule, I kind of combine two things that go along together. Number one, always unplug electric devices before looking inside of the devices or servicing them. So for example, if you have a problem in refrigerator, obviously you have to unplug first. And by the way, talking about unplugging, a lot of student does this without noticing. Pull the plug, not the cord. Cord can be damaged. And like I mentioned, damaged cord means exposed wire, which is also equal to short circuit problem. Your body can become a circuit because our body has sweat gland and we have our body oil that is possibly conducting a little bit too, bunch of ion solutions, so you will get zapped. The next one is do not put anything into an electrical outlet other than proper plugs for electrical devices. This is no-brainer. As soon as you put, let's say, chopstick, shove it in into the one on the left, one on the right, to the plug-in, and you touch it, well, good luck. You just made yourself as a part of the circuit. You're gonna get toasted. And we talk about power line. Simply stay away from the power line. Don't even go nearby. You're gonna get short circuit situation, and it's not gonna be pretty because it's gonna be way more higher than whatever milliamp that your body can handle. So we talk about this grounding terminal over here. I'm gonna explain to you why a lot of expensive electronic devices like laptop have three. Some of those small electronic devices, let's say hair dryer, even though it does require a lot of energy, but hair dryer they use 2N. So what does that do? Three prongs. The third prong, which I'm specifically talking about this guy over here at the bottom, they has a specific wire that leads to the ground, and this is something I like to highlight because grounding means electron will safely go to another pathway to the earth without going through you. The other safety related features that we have in our house is breaker and fuse. So first of all, fuses and circuit breaker, their job is literally interrupting a circuit for the safety, especially in the situation where you have too much of current is flowing through. So this is a situation where, for example, you're using hair dryer and at the same time you plugged in whatever, I don't know, charger of your phone, etc., etc. Let's assume that you're using a lot. Hair dryer is a notorious one. And if you notice, a lot of bathroom has its own circuit breaker when you go to the basement. Or maybe one or two extra room, but not much other than its own room, which is bathroom. But in any case, Whenever there's overwhelming amount of current happening, fuse start to melt, circuit breakers start to shut off. So here's a picture of a fuse on the right side. It actually composed of one tiny thread that you see over here. Basically, this decides to melt. Fuse contain a thin metal pieces that has relatively low melting point. So if there's a lot of overcharge happening, overuse, if there's overuse electric devices, we have a lot of current. And if you have a lot of current, think about strong river. When you do hiking, then you will notice that rocks around are actually more smooth because of a lot of friction, which means high heat energy. And in order to prevent any of a fire, fuse actually decide to melt. And if this part is cut off, then we have incomplete circuit, which is a good thing because you're not going to have a fire damage to other places. Most of the time, circuit breaker is what people have because fuse, you need to replace fuse every single time whenever there's melting going on. Circuit breaker has a special wire that heat up if there's too much current. So this special wire is actually connected to a button system, if you will. If there's a lot of heat happening, you have a different length changes. It's kind of like this. If you heat something up, it expand. If it expand, and when I say expand, most of the matter expand. Let's say even plastic, when you melt, it actually spread out more. Metal, it actually can extend when you apply heat. Think about the blacksmith situation back in medieval time. But in any case, circuit breaker has a special wire that changes length, and because of that, we are no longer have a contact. Contact is the one that broke, and that's how you're gonna have a switch back and forth. This breaker is like a switch more. So we talk about plug types. Let's think about which one has a grounding feature in here. Right now I can see that type B and type D has a grounding situation because of this third prong, and you can double check grounded, something like that. The one thing that you need to be careful in Canada is, like I said, this type, because first of all, look at the amperage current. It is 15 amp. It's way beyond our milliamp boundary or threshold, if you will, that human body can handle. So if you have any electronic devices like this, especially be careful. If there is any devices that you're using but the prong is gone, then you actually have to bring it to service or replace it. What about type E, F, G, H? Which one do you think has a grounding purpose in here? The answer is, it may surprise you, everything has a grounding feature. Some of you guys may wonder, okay, Mr. Kim, H and G I understand because of this third prong, but E and F, where's my third prong? This is unique feature where the prong is actually attached at the plug hole over here. So can you notice that when it comes to prong, it's actually attached to the wall? This is the one that uses grounding. So these guys, whenever you see third feature, third terminal, you need to understand that they're the one that has a grounding feature. I mentioned to you a little bit that 110 volt versus 220 volt. So 110 is what Canadians are using. 220 is what Asian country like Korea is using it. Which one is benefit? Long story short, 110 volt supply, they have less likely to electrocute people. So in terms of safety feature, this is better, but 220 volt is more efficient. It actually has higher potential difference. That means I can send more energy, so it will require low current. If you think about it in that way, 220 volt also is somehow indirectly involved with the safety feature too, because low current, means less dangerous for human body. That's why. Our last lesson portion of today is lightning. Lightning is a huge amount of negative charge. Huge amount of negative charge that is located, oh my goodness, specifically at the bottom of dark cloud. But in any case, it's a huge amount of negative charge that is gathered in the clouds because of interaction between air molecules and water molecule that is inside, and they tend to seek the highest point of horizon to discharge. I also like to put one thing over here. Oh Lord. There you go. Highest point, when I mention about highest point, highest, so tallest and pointiest. This is one of the reasons why really tall tree, they sometimes have lightning and that cause mountain fire, forest fire, or really tall buildings, they always have lightning rod. So I gave you an example on the right side. It's a picture that captured lightning strike that goes to a tallest and pointiest building that you can see. I forgot which city this was, but in any case, because tall buildings are a neutral target for lightning strike, lightning rods are often added to their peak. If you have, for example, a tower that look like this versus tower that look like this, I want you to think about the surface area. Surface area of building 1, surface area of building 2. Which one has a smaller surface area? Which is this one. And why lightning like the pointiest one is because this tip, you can have a concentrated positive charge compared to surface area number 2, less concentrated positive charge. I want you to look at this GIF that is located at the bottom part. Lightning is a fast procedure that happens between the negative charge. I'm gonna put negative charge are more concentrated on the bottom part of the cloud. I know that the building itself is neutral. Can you see that it has a positive charged area? Because neutral means you have to have negative and positive equal amount. So these guys are finding its place because always remember, negative attracted by the positive. Generally, a house doesn't burn or any type of car, vehicle, tall building, they don't get burned because where would the electron go? Eventually, they will go to the ground. back to Earth, something like that. So lightning rods are connected to the ground with a wire. The lightning discharge is conducted harmlessly to the ground. As long as this grounding part works, it is harmless. The only time that this can be a problem is, what if it's tree? Well, trees burn first. They don't have much of a resistance in it. Remember, they're a living organism too. So like I said, this is a good picture that describes how dark clouds tend to gather together, and at the same time the lightning damage can get more and more serious. Is because, can you see I have cloud number 1, cloud number 2? Opposite charge attract also, so you can have a connection between between the clouds to cloud, become more charged, and it will become stronger. Lightning attack towards the ground, tall building or trees, whatever the tallest and pointiest structure that you can think of. If I elaborate this as steps, the first step is clouds create friction between water molecules. Negative charge goes lower while positive charge go upper part of the cloud. We call it charge separation. We learn about this. Step leader is the one that you are witnessing on the right side. They're the one that create a path. It's like a circuit. And a large amount of electron travel from the bottom of the clouds to the ground because ground is relatively positive. And top portion is relatively negative. That is today's lesson, folks. It was more heavy lesson compared to the last time. Your homework is doing all the science log activity followed by in that booklet.